This little quick video is going to be just about alpha levels. An alpha level is basically, it's your cutoff line. In chapter 20, we talked about if we had lots of evidence or weak evidence to say that my null, I have evidence against my null or for my null. Well, we need somehow to be able to define what is a rejection of the null and what is not. It can't be based on subjective decisions like, well, I felt like it was like. That's not scientific enough to use. So an alpha level is basically your way of saying that, well, if my p-value drops below this number, then we're going to reject the null. And on the screen you see here I've got two different alpha level pictures drawn. This is your one-tailed test on the top. If you have a one-tailed test, then it means the entire alpha level, the percentage, is located on one end. Now this could also be at the top end. I just drew it on the bottom. But if I'm using a p-value, and it's all, of course this would be a less than problem for my alternative. If my p-value dropped below 5%, then I would reject the null. On the bottom one, we have a two-tailed test. What that means is, notice the similarity is that 95% is the same in both areas. If but in the bottom one you have two things that are happening. You have 2.5% and 2.5%. So when you have a two-tailed test, your alpha level has to be cut in half. So think about this as a threshold value. This threshold is basically if we had a let me just use this for an example. If this is our p-value on the side here, if the p-value, let's say this is 0.2, this is 0.1, let's say this would be 0.05, and this is 0.01, and that would be 0.001, and so forth. What we're looking at is, if my p-value drops down, let's just assume that we have an alpha of 0.05, just to kind of go with the discussion. Then what I've done here is I've drawn that line. If let's say that the p-value was 0.06, then my p-value is going to end up being 0.06 would be here, so I would fail to reject. And so anything above that dotted line, I would fail to reject. Okay, anything at the bottom, anything below that, I'm going to reject that null. So think about your p-value as that threshold level. Majority of the time, the problem is going to tell you using a p-value of whatever. If no p-value is given, no p-value is suggested for you to use, then you're going to simply choose whatever you want. It's most common that we use 5%. That's kind of why I've done that here. But there is no rule, there's no law that the p-value must be, or the alpha level must be whatever. The lower your alpha level is, the more evidence is required to reject the null. So if you want a stronger test, you want to make the alpha level smaller. If you want a weaker test where it doesn't require as much evidence to reject, then you can increase your alpha level. So the alpha level that we've gotten drawn here is 0.05, and any time when you're trying to decide alpha levels, 0.05 is a great place to go. And that's pretty much what an alpha level is, or also known as significance level, because what happens is when it falls into the rejection region, what we say is that we now have a significance or a significant event, or that that I have significant evidence, or it's statistically significant. All those things come into play. We reject our null when the p-value drops below our alpha. And that is very important. A lot of the times people get that backwards. We reject the null when our p-value drops below our alpha level or our significance level. And that's what you want to walk away from the book with alpha levels. It's just about, when do I reject the null or not? Okay, it can't be left up for an emotional decision like, I think that's good, or no, I don't really like that. It needs to be, here it is. It doesn't matter who does the test, they're all going to have the same type of conclusions, and that's alpha levels or significance levels. They are equivalent.